Hello, ladies and gentlemen. Okay, so we're talking about arithmetic series here. Now, a series is a sum of all the terms in a given sequence. So that's where you're going to take all the commas and you're going to replace them with plus signs. So this is a series where this would be a sequence. The difference, once again, our commas are turned into plus signs. S sub n will represent the sum of the first n terms. That means if it was S sub 3, that would be the sum of the first 3 terms. 1, 2, 3. So you'd add the 8, the 2, and the 5 together. If it was S of 5, you'd be adding 5 terms. 1, 2, 3, 4, 5. So then you'd be adding all of these together. So S sub 5 means adding 2 plus 5 plus 8 plus 11 plus 14. 14 plus 11 is 25 plus 5 more is 30. 8 plus 2 is 40 in total. All right, so here's your formulas you need to know. So n over 2, 2a plus n minus 1d. Or S of n equals n over t bracket a plus tn. Now, before you can have an arithmetic series, you have to have an arithmetic sequence. So that's where that tn comes from. That tn is actually the nth term in the arithmetic sequence. Now, there's a story about a young man named Gauss. A young man named Gauss was a bit of a pain in math class, and his teacher thought he was a pain, so he told him to go away and add up the first 100 digits of the positive integers. So remember, this is back in 1777 approximately, and so Gauss was sent to go and do basically this: the sum of the first 100 positive digits, 1 plus 2 plus 3, ... plus 98 plus 99 plus 100. Well, his teacher expected him to sit down and add all of those up, but Gauss said no way. Gauss said if this adds up to the sum of the first 100 digits, so does this. 100 plus 99 plus 98 plus ... plus 3 plus 2 plus 1. And then Gauss said, you know what, I'm going to add up all of these. All of these little columns is going to be 100 plus 1, which is 101. This is going to be 99 plus 2, which is 101. This will be 98 plus 3, that's 101. Plus, 101, 101, 101. How many 101s do we have here? Well, 1 column, 2 column, 3 columns, all the way up to 100. There's going to be 101s there. So that's actually going to be 101 times 100, and that equals to 2 times the sum of the first 100 digits in the positive integers. And so then what Gauss realized was he's got twice the number that he wants. So what he's going to do is divide by 2. So he divides both sides by 2. And he gets the sum of the first 100 positive digits. So it's 100 times 101. I just reversed the order because I have no reason to do so, but I felt like it. Dividing by 2, and so that'll give you, let's see if I do this right, and it's going to be, and that's the answer that he came up with. And this is definitely related to the formula that we have here. If you take a look at this, this is a, so that would be the first term. This is t sub n, so that would be the last term. So he's adding these two terms. And the dividing by 2 is because when he added those two terms up, he was getting twice the sum of the digits. So here is definitely seen, this is definitely seen in the logic of this. Now the next thing to realize is, see this t sub n? I want to take a quick look at that. And that formula here, S of n equals n over 2 a plus t of n. Remember, in any arithmetic sequence, that t sub n is given by a plus n minus 1 d. So if I take this t sub n and plug it in for that t sub n, I get S of n equals n over 2 a plus a bracket, or another plus, sorry, n minus 1 d. So this part got plugged in for the t sub n. Gives us this. Collect like terms. A plus a is 2a. Plus n minus 1 d, which is just another way of having the exact same formula. So we use this formula when we have a, n, and d, and we use this formula when you have a, n, and the last term that you're summing up to. All right, that's our introduction. I'll be back with some more examples.